We are continuing to work on multiplying polynomials today. Yesterday we did monomial times a polynomial and also a binomial times a binomial. Today we are going to go to not specific polynomial numbers, just polynomials times polynomials. I'm going to show you two ways to do it. You can pick your favorite. One of them we kind of talked through yesterday, but no matter what method you choose, remember you need to write your answer in standard form. So the box method works like this. This is what we talked about yesterday. Today you have to make your own box. So you have to figure out how many terms are in each polynomial. So in this one, this is a binomial. This is a 2, and this is a trinomial. So this is going to be a 2 by 3. So I am going to make a box. Two by 3. I'm going to move this up here because I want to actually write it right there. So maybe give yourself a little space when you do this. And I'm going to write my terms separated in this box. I'm going to put my binomial, my 2, so I'm going to have 4x and minus 7. And then along the top, I'm going to have my trinomial, 3x squared minus 7x minus 8. And then all I'm going to do is multiply to get what goes in each box. So I'm going to have 4x times 3x squared. That is 12x cubed, right? Because I have 4 times 3 is 12, and then I'm talking about 3 x's altogether. 4x times negative 7x, that is negative 28x squared. 4x times negative 8 is negative 32x. Negative 7 times 3x squared, that is negative 21x squared. Negative 7 times negative 7x, that's a positive 49x. And then negative 7 times negative 8, that is a positive 56. Okay, so what you're going to do next is you're simply going to write out the terms in the box. So we had 12x cubed minus 28x squared minus 32x minus 21x squared plus 49x plus 56. I need to condense this so that A, all of my like terms are combined, and B, it's in standard form. So I'm going to do these kind of in one step because I think that we can handle it. So I don't see anything that goes with this 12x3. I also see that that's the highest exponent, so I'm just going to rewrite that way. Looking at my negative 28x squared, I've got a negative 28x squared, and I've got a negative 21x squared. So we're going to combine those. Negative 28 minus 21, that is negative 49x squared. Remember, when you add or subtract terms in a polynomial, your exponent does not change. Only when you multiply does your exponent change. And then I have negative 32x and positive 49x. Negative 32 plus 49, I believe that is 17x. And then I still have this leftover constant term. So I think if I did mental math correctly, I hope I did, this is my answer. This is one method. You can do the box method if you sort of like the organizational layout of the box. The other method one I kind of like. I like columns. Yesterday we talked about FOIL. This is sort of like FOIL, except for the acronym of FOIL only works for a binomial times a binomial, because that's the only time we have the first two terms, the outer two terms, the inner two terms, and the last two terms, and that's all of them. So this is sort of like FOILing, except for there's not an acronym for it. So what I'm going to do is I'm going to start with the first term of my first polynomial, so the 6x squared, and I am going to distribute that to everything, all in a row. So 6x squared times 5x squared, that is 30x to the fourth. 6x squared times negative 5x, negative 30x cubed. 6x squared times negative 3, that is negative 18x squared. Now I'm going to move to my second term. I'm going to do the same thing, but when I apply the distributive property, I'm going to put it in the appropriate column. So 7x times 5x squared, that is 35x cubed. Since this is an x cubed term, I'm going to put it underneath the other x cubed term. I'm going to make my new column this way. So then I have 7x times negative 5x, that is negative 35x squared. And then 7x times negative 3, that is negative 21x. And finally, I'm going to do the same thing with this final term in my first polynomial, and I am going to distribute it to everything. But just like before, I'm going to put it in its own column, and I'm going to line it up so that the exponents are alike. So negative 2 times 5x squared, that is negative 10x squared. Negative 2 times negative 5x, that's 10x. And negative 2 times negative 3 is a constant, positive 6. So I have all of the distributions. I know I've covered everything. Now to make one expression at the end, I'm going to add these factors here, just distributions here. So 30x to the fourth has nothing to add to it, so I'm just going to bring that guy down. 30x to the fourth. I have a negative 30x cubed plus 35x cubed. Negative 30 plus 35, that's a plus 5x cubed. A negative 18 minus 35 minus 10. This is the big one. So this is going to be I believe this will be negative 63x squared. And negative 21x plus 10x, that is negative 11x. And I have nothing to add with this constant term over here. So this is my answer. 30x to the fourth is 5x cubed minus 63x squared minus 11x plus 6. I think that's right. It's all mental math, so I hope it's correct. Now for these examples, I want you to pause and do them using the method of your choice. Personally, I like the column method, but I'm going to do one of each. I'm going to do number 1 in the box and number 2 in the column. You don't have to do it one specific way. You can pick your favorite way and do that way both ways. I don't really have a preference, but what I want you to do right now is pause this, try these yourself, and then see if you get the same answer as me. Here we go. should I think I'm getting? Disagree with me, let me know. It's possible I made a mistake. So both of these methods work every time. So I would recommend picking one you feel more comfortable with and using that one. The more practice you get with one, the better you will feel. You have the rest of the time to work on homework.